So today I'm going to be talking about improving build speed and bundle sizes with Angular Ivy. Just a brief introduction. My name is Joel. I work as a member of the Widgmo team for Grape City, which is a web components library. So let's see. So first off is what is Angular Ivy? Ivy is Angular's newest compiler. It replaces the Vue engine compiler, which has been Angular's default compiler since Angular 4. It came out with Angular 8 and has become Angular's default compiler since Angular 9. There were really two key points that the Angular team was trying to make here with the change from Vue engine to Ivy, and that is to reach better build times through more incremental compilation and to reach better bundle sizes through improved tree shaking compatibility. Now just a quick overview on bundling and tree shaking. So bundling is the optimization technique that allows us to merge multiple JavaScript files into fewer files, and that allows us to reduce the number of page requests users make to the server, allowing pages to render more quickly. Tree shaking is a term used in the JavaScript context for dead code elimination. The execution flows of a program can be represented by a tree of function calls, so that functions that are never called can be shaken or removed from the tree and not included in the final bundle. Two of the more popular ways that we bundle applications is by using CommonJS and ES modules. These are both bundlers that you can use to shrink the number of files that you're serving. Now you want to avoid using CommonJS to bundle your applications. CommonJS results in larger bundle sizes when building. It's designed to be used on server-side applications, so it's not optimized to be used on client-side applications. And the Ivy compiler also at this point warns you if you're bundling with CommonJS. And you can see here just a quick little code snippet of import functionality. The top one is CommonJS import, and the bottom one is ES modules. As you can see in the CommonJS, you're actually able to pass things like variables into the file paths, whereas with ES modules, it has to be a static string. And the reason that CommonJS can take dynamic approaches like this is because how dependencies are loaded. CommonJS loads at runtime. They're loaded, instantiated, and evaluated all at once. And this is what allows us to do things like pass variables into file paths. Now, because this is all done at runtime, tree shaking is pretty hard to do with CommonJS. Now, ES modules are more static, like as you saw, passing in a static string instead of a variable into the file path. So that makes them more statically analyzable. The loading, instantiating, and evaluation is broken up into 3 different phases, and they aren't required to be performed at the same time, meaning that we can perform more effective tree shaking. Ivy can make better use of ES modules and bundling in the Vue engine because of how Ivy updates the DOM versus how the Vue engine would do it. When the Vue engine updates the DOM, and you can kind of see this in the Vue engine render pipeline image, it makes a note of all of the associations in the HTML properties and TypeScript properties. It then creates a binding between these associations. When Angular gets notified of a change, all of the bindings get reevaluated, and the changed binding is marked and updated. And then the template data is taken by the Angular interpreter and transformed into the DOM with the latest updates. With Ivy, it gets rid of the template data and handing that off to the Angular interpreter, so that's no longer included. Instead, you have a set of template instructions that are generated using the template HTML that we write. The template instructions then hold the logic that instantiates components, creates DOM nodes, and runs change detection. So you can see here, it goes directly from the template HTML to the template instructions into the DOM. You don't need to include the Angular interpreter with that anymore. That means that there's less that we need to include when building and bundling our final application. And finally, we get to the actual bundle size decreases that you should expect to see. So for small and large applications, the Angular team says that you should expect around a 20 to 30% decrease in the size of the bundle outputs. For medium-sized applications, it's a little bit smaller. So in there, you're likely to see 15 to 20% instead of 20 to 30%. And then we've actually done some testing with our own component library for bundling. So as you can see in the grid on the left here, the second column is the final size in kilobytes for Ivy, and the third column is for the view engine, and then the final column is the percentage decrease that we're seeing between bundling with Ivy and the view engine. And then down at the bottom, you can see the average percent decrease is about 30%. And then we get to improved build times. So in the view engine compiler, each build would force Angular to recompile everything inside of your module, and it would do so to check to see what had been changed. The reason that it did this was because components could be using internal details of another component. In the Ivy compiler, each component references the directives and components it uses only by their public APIs. And if you modify an internal detail of a component or directive, the application will automatically know what other components use the code that's been modified, and it only updates those components. And this kind of leads into the ahead-of-time compilation becoming the default. With Ivy's improved build times, Angular team has made ahead-of-time compilation the default compilation method over just-in-time. The benefits of using AOT compilation are things like faster rendering, fewer asynchronous requests, smaller Angular framework download size, detect template errors earlier, and better security. And that's it. That is all that you need to really know to get started with improving bundle sizes and build times with Angular Ivy.